Hello and welcome to Better Together at Science with Shinrai Sensei. And in today's episode, we're going to be discussing two phenomenon in science that are polar opposites, but have similar names, right? And so you have the concept of nuclear fission versus nuclear fusion, right? So nuclear fission versus nuclear fusion, both of which generate massive amounts of energy, but work on completely different principles and completely different theories of science, right? So fission is based off of the concept that we are all familiar with from Albert Einstein, which is E equals mc squared. Energy equals the mass of an object times the speed of light squared, right? And so nuclear fission is when you split atoms apart by firing electrons into the nucleus of an atom and forcibly splitting the nucleus apart. When the nucleus comes apart, the amount of energy that is going to be generated from the splitting of that nucleus is going to be equivalent to the mass of the particle involved times the speed of light squared, right? And so this is where we came up with the concept of atomic bombs and nuclear bombs, hydrogen bombs, things like that. So the energy released from this reaction is what creates the explosive and incredibly powerful and damaging force that we know as an atomic explosion or a nuclear explosion, right? So nuclear bombs are much more powerful than the original atomic bombs were, right? The atomic bombs, you could only get a measure in the kilotons usually, not in the megatons. And for those of you who don't know, kilotons is 1,000 times smaller. 1 kiloton is 1,000 times smaller than 1 megaton. That's the difference. So when you're talking about explosions, your atomic bombs are hundreds, if not thousands, of times smaller than what we are accomplishing with nuclear bombs. And nuclear bombs have become so strong that we now have what's called a hydrogen bomb. And the hydrogen bomb is a bomb that generates so much energy when it explodes that it actually, because of the heat created in the moment of that explosion, the amount of heat is so intense that it actually starts fusing hydrogen atoms together. And that's why it's called a hydrogen bomb, is because the heat is so intense, fusion starts to happen. And so fission can lead to fusion, but fusion doesn't lead to fission. At least in the usual sense, right? Most of the time, fusion will not lead to any kind of fission reaction. Maybe by accident, a stray electron from the fusion of two atoms can speed off and go split another atom somewhere else, but highly unlikely, right? So nuclear fusion, so fission is splitting an atom, right? Nuclear fusion is combining two atoms together, usually two atoms, right? And usually the easy way to do fusion, if you're going ahead and looking at it from a pragmatic perspective, the easiest way to do fusion isn't to combine, if I want to get an element with 8 protons in it, then I need to smash 2 4-proton atoms together. Actually, the easier option would probably be to just smash hydrogen atoms into, well, first it'll be a hydrogen atom, then it'll be a helium atom, then it'll be a lithium atom, and then it'll be, I don't think it's oxygen. No. Element number 4 is slipping my mind at the moment. But so on and so forth until you reach the 8th element, right? So it's actually would be, energetically speaking, easier to smash together hydrogen with a larger particle and, generate the larger particle based on that than it would be to smash 2 large particles together, because the amount of force needed to take those 2 large particles and push them together is extremely high compared to just taking one hydrogen atom and smacking it into something larger. So, for all intents and purposes, fusion generates more energy than fission, by the way. Fusion generates much more energy. And if we can find out how to do fusion without having to attain temperatures that are like equivalent to a hydrogen bomb going off or equivalent to the surface of the sun, then we can actually harvest fusion to do magnificent things. Many scientists, both in physics and in engineering, are currently working towards creating fusion reactors, but obviously, due to the fact that fusion, as far as we've been able to find it in nature and in our own methods, fusion is almost exclusively relegated to extreme heat environments. And so the only way that we can think to do fusion outside of that would be like through particle accelerators, which, once again, you have massive amounts of energy that need to be put in. That's the greatest problem with fusion, is how much energy needs to be put in. According to everything that we've found so far, the greatest problem with creating nuclear fusion is how much energy needs to be put into the product in order to get more energy out of the product. Now, granted, there is a lot more energy going to come out of fusion than comes out of fission, right? Fission, the only way we've come up with fission being a worthwhile method to generate energy is basically redoing the steam engine, but with fission as the heat source, right? So you're using uranium, plutonium, and thorium and things like that. You're using those to generate amounts of heat that then boil water, which then spins a turbine, and it's just basically like a standard like coal reactor, or a standard standard large heat source steam engine would be what fission really runs on. Whereas fusion, if we can really figure out how to harness these energies and not have to resort to turning them into massive steam engines and just taking that energy directly to a source, then we'd be a lot better off. But currently, our only way that we can use these things is to have massive amounts of energy would have to go towards fusion, and both of these energy sources will be used as a source of heat, which will then create steam, which then will make a turbine spin and electricity from the static electricity from the turbine spinning, right? So fission is splitting, fusion is combining. And fusion is the processes by which stars create new atoms, right? And in the next episode, I'm going to go a little bit further into fusion and how fusion and the battle of fusion and gravity creates stars, and is actually one of the largest reasons as to why stars die. But I think that's kind of a basic rundown on the fusion versus fission. And if you guys have any questions, please leave them in the comment section below. I look forward to hearing from you guys. Thank you guys to all of my lovely subscribers, and I will see you guys in the next science episode. Peace.